So let's talk about some different geo-replication patterns that you're allowed to do. So this one is sort of the default full mesh replications, but it's showing you all the different capabilities you have, right? So Pulsar can replicate between multiple clusters simultaneously. It is not bound to have just point-to-point like you do with other messaging systems. And again, all the replication occurs asynchronously. So again, this is kind of showing the result of that previous walking through. We've created a topic. We created a namespace. We've defined 3 different clusters: US East, US West, US Central, coming in here. So all data that gets published, let's say coming in from a client, he connects to the US Central, he publishes it here. The data is going to get geo-replicated across all these different regions asynchronously because we've configured the policies in such a way that it's full mesh. These individual ZooKeeper nodes here represent the global configuration store, right? So this is a stretched cluster. This is holds the metadata about the Pulsar instance. Each one of these ZooKeeper nodes are a part of that quorum of the that configuration store. So each one of these talk to one another. It's very it's mostly read only. You read the data. Again, you set the cluster up once. Once it's set up, you pretty much leave the data alone. So having a copy that's replicated locally makes it easier to access that data. It's just the best practice on that, and this is how the data flows. Again, if you had another client came in and published to the US East on that same topic, it would replicate automatically to the Central and West. So it's all handled automatically for you. Now, if you want to set up, there's some different patterns that you want to set up involved. We have bidirectional replication. Here, this is active scenario where the data that is published on the US East is replicated to the Central and West, and vice versa. So this is basically saying that all of the data that gets published there is the same, more or less conceptually, in the East, the West, and the Central, regardless of who's publishing the data. Now the order in which it arrives there is going to be slightly different because obviously locality data is going to be there first versus geo-replicated data, and it's non-deterministic of when the geo-replication occurs. But as far as a data set perspective is concerned, all of that data in all these regions should be identical. If you're using etcd as your local metastore, do you still need a global ZooKeeper for replication? At the moment, that is the only thing that's supported for instance replication. We are working on replacing etcd across multiple regions. It's a matter of configuring these etcd instances in different regions to talk to one another. That's the real barrier. So if you wanted to do it, you would still have to set up a ZooKeeper cluster for your Pulsar instance configuration store. So this is the active pattern. You set up geo-replication in both ways. Data is always flowing in from one direction to the next. Data published in one region makes its way to all the other ones, asynchronously. Another pattern to do is using with the front is to have an active passive or active standby scenario. This is primarily fronted using a load balancer. So the Pulsar clients connect to a known endpoint. They are always routed to what's considered the active cluster at this point in time. Active traffic comes in there. All data is published here. All requests are served from here. And there's a background process geo-replicating the data automatically in both directions. But since it's only coming into the East, or the active one at the moment, the replication is unidirectional at any point in time. Now, let's say the load balancer detects a complete failure of the US East cluster. The proxy goes down. That region goes down. You can't access it for some reason. The load balancer is what handles switching you over to the US West region. You have the majority of the data there minus whatever was not replicated during the data in flight, because there's that little latency. Again, it's the network latency, so it's minimal, but there is some data that could be lost in the scenario. But you immediately switch over to the US West and you start consuming the data there. You can pick up from where you left off. Once we talk about replicated subscriptions, that's handled as well. And the load balancer handles all this for you, and you've made the data as available as possible with this, right? Eventually, again, you can then switch back. Eventually, if the US East comes back on, you can have a bias to switch back over to the US East. The West has been buffering up the data, so it can be geo-replicated back. It will not send it if the cluster's down, so it just sort of buffers it, gets behind. But eventually, when the US East comes back online, it'll geo-replicate the data that was back online to get them back in sync, and then you can switch the load balancer over at that point in time. So this is your active-passive scenario. as well. And so as I mentioned in the previous slide, the other part of this equation of having a seamless failover for your clients is having your subscription replicated. So again, a subscription in Pulsar underneath the covers is a cursor. It means, among other things, it controls who can access the cluster. But the biggest benefit it gives you is it stores your cursor position internally inside BookKeeper. So in the event of a failure, you know where you were in the last message. And that's controlled by the message acknowledgments on the consumer side to say, I've consumed this message, move the cursor forward. You can enable replication subscriptions to have that metadata sent over as well. That way, when your consumers in this active failover scenario occur and they reconnect on the new subscription, they have a known starting point. If you do not set up replicated subscriptions, they connect, they don't know exactly which message to start with, right? They could start with the earliest one, the latest one. You've lost track of that. So using this replicated subscription, you're copying that metadata over there as well, track of where you were in the consumption pattern to make sure that you don't inadvertently experience data, quote unquote, data loss because you've lost place of where you are. And maybe you skip processing of messages that were replicated, but you've lost track of where you were. So you don't want to lose data just by not processing them. So this is how it's done. When you create a subscription, you just set it to be replicated equal to true as part of your Fluent API. That's it. Everything else is taking place, handled for you under the covers automatically, assuming policies are in place for a replication on that namespace, which is generally how you set it up for that. So this just handles that replication of the subscription as well, and it's copied for you every time it's an acknowledgement is made on the local cluster. The acknowledgement is sent over to the replicated cluster, and it updates that subscription as well. So there are some limitations to this as well. So when you enable a replicated subscription, you're creating a consistent distributed snapshot, between two messages IDs. So periodically, these message IDs, are synced up every second. The snapshot frequently is done every second, and you can control this. So again, these message IDs from different servers or different clients coming in could have the same message ID. So you have to have these snapshots to keep track of where they are, and you keep them up in sync. This is for the message deduplication. Message deduplication is handled by sequence IDs and message IDs. So obviously, if you're publishing to different clusters, you want to make sure that these IDs are in sync from different producers as they get replicated across, and these snapshots help those message IDs stay in sync, basically. And by default, they're synced up every 1 second. You can make that more aggressive inside the broker.conf to make sure that you don't have message ID skew between the two and end up with duplicate data because of it. Key difference between the global configuration store and the manual cluster is where the metadata for geo-replication is stored. Again, this goes back to the different configuration stores and the etcd question, right? So the etcd implementation configuration store is configurable for the manual cluster. Each cluster has its own metadata. We can do this with etcd, and they can have their different replication configuration metadata internally stored with there. The global configuration store, which is the stretched Zookeeper cluster, all share that same replication metadata there, and all of the clusters have a fully replicated relationship with other clusters. So whatever configuration you set in the global one, that applies globally, but you can override that with a manual cluster. You can have specific unidirectional policies, and that's done in the local metadata store of every individual cluster, right? So if you define a configuration replication rule at the global level by connecting to the global metadata store and enabling it at that level, then it's set up to be bidirectional at that point, and everybody knows it's going from cluster A to cluster B. If you set it up at an individual cluster level to say, I want to replicate just to US West, that's how you set up unidirectional clusters for like the active passive scenario. We saw that one cluster is only aware of the other one. It's only aware of where it's replicating and pushing out to. It has no inbound replication as well. So that's the slight difference between those two. So use cases, let's talk about, we talked about migration, right? So let's say you want to move all the data from a namespace from cluster A to cluster B. These are the 4 steps that you would have to walk through to do that. First, you enable geo-replication between these 2 clusters. So again, you go to one of these clusters, you log in, you go to the admin tool, and you update that tenant, and you say it's allowed on both of these clusters. for this tenant. Make sure that that's in place. It doesn't matter which cluster you run this on. You're setting up for both. Then you set up geo-replication from cluster A to cluster B for that namespaces. So again, you're saying I want to set up, I want to add these clusters here and enable geo-replication at this point. By setting up that they're part of that cluster, you've enabled geo-replication on that namespace. Then you unload the namespace to trigger the replicator rebuild on this. So basically, you're forcing that particular namespace that's currently being served by the broker to be unloaded at that point, and then replication should start, right? So you're forcing it to say, hey, I'm out of sync at this point. The topic goes off, the namespace goes offline, that individual broker, that starts the geo-replication process manually, and you wait for all that data to be copied, and then you can revert that process and turn off basically what you just did by disabling geo-replication, right? Go back to line 2 and set the clusters, to empty, so that it is no longer geo-replicating. So this is a one-time thing. I want to kick the data over. You're forcing it to offload. And then once you've completed all the data copy, you turn off geo-replication. So it's a one-time move the data across the data center sort of scenario. And this is one technique we've seen that works if you want to set up geo-replication for other one-time uses as well.